back in Brazil in 2016, and then we brought Zasso to Europe, to Switzerland in 2016. Let me start with a number, 0.06 millimeter. 0.06 millimeter, that is the diameter of a root of a hair. And yet, when you pluck your hair and try to remove it, you cannot do it properly. The root is not removed, right? The root is actually connected to blood vessels, to tissues, and it's really, really hard to remove it, and so it regrows. And so that prompted us to think about not just what's above the surface, but what's beneath it, and to look at the root of the problem when thinking about weeding. That's our focus. You see here on the left-hand side, the air system and the root system of a root. And clearly, if you damage the air system with technology, there is a probability that it will recover at some point. Now, if you damage the root system, it's gone. The nutrients no longer feed the plant. The plant is deficient in nutrients. The plant will not regrow. So our focus is to really treat the roots and the deep roots of the plants. What we do is to apply high voltage, low currents at the root level in a controlled fashion. That current is applied by electrodes that forms a sort of a closed circuit between two poles. You see on the right an effect before and after. And if you think about how, another way of thinking about it, when you look not so much here but into light bulb, you think about the current that goes through a filament that heats up the filament. And that heating is what's going on here with the plant. The plant tissues, the membranes, are going to blow, and that's going to reduce the photosynthesis process. That's what's happening here. And you see here the evolution of a plant. This is over a one-day period. You see the evolution. The plant starts decaying and is no longer vibrant. So no more nutrients, the plant dies. Let's see here if you can see better. This is a CTZAS. CTZAS is it's a system, like all systems have two main subsystems, the front applicator and the supply unit. The front applicator here has two rows of electrodes made of steel. The applicator width here is 1.20 meters. And on the back you have a supply unit which has power modules which transforms electricity into high voltage, as well as a generator and a cabinet. So this is mounted on a holder, C65. It's going around 2 kilometers per hour. You probably saw at the beginning, behind the supply unit, there's some grounding device that sort of picks up the residual current. And that goes, so that's about 8,000 volts being applied to the plant. And you see here on the, let's see if this works. You see here the current, the two electrodes, and the current going through the roots and then closed. So the first one touches the plant, and the back one picks up the current. Here are two images. One is a coffee plantation in Brazil. The other is in Germany. It's in a cemetery. And you see here the very clean effect. The reason for that is it's a touch, the mode of action is a touch-based system, which means only the weed that is touched by the electrode will be affected. There is no traveling around of the electricity in the soil, picking up expensive vines or damaging other crops or other plants. Only the plant that is touched by the electrode. I think it's important to realize it's an agronomic process. So there are a number of parameters that matter when we apply electricity. Ultimately, what matters is how much power is consumed by the root of the plant, right? So that's the only thing that matters. How much power is consumed by the root of the plant? And for this to happen, you need to think, there are a number of parameters that are impacting this. One of them is the physiognomy of the plant. So if you think about the transfer of electricity from the electrode to the leaf, the broader the leaf, the more energy is captured by the plant, the more electricity, the more power goes into the root. If you have a monocot, a we say in French graminé, but also a narrow leaf, that would be a little bit more difficult to treat. So you have to reduce the speed to have a higher time of contact between the electrode and the leaf. So that's an important distinction to make between the types of plants and also the stages. So we tend to recommend treatment earlier in the season, around March, April, and then another one around June, July. Soil is important. The drier the soil, the better. The drier the soil, the better, because you want the current to remain in the leaf and in the stem, and not to be dispersed. If it rained heavily beforehand, not great. That means the water is trempé. The weather is the soil is very heavy in water, so it's not as great as if the soil is dry. If it rains afterwards, no problem. And of course, speed is something that matters. So weed density is a parameter. The more dense, the slower you want to go to apply the electricity into the weed. Here is the solution that's in the good hands of Kirsten, and thank you for taking the innovation forward here in the UK. Let's see if this works. Yeah. So this is another type. We saw the CityZaz. This is the Zap Wheeler. It's powered by lithium batteries. You still see the two rows of electrodes. This is using batteries from Planck in this case, but we're working with others now. We will. 60 centimeter width, and this is being pushed forward. This is the first. We're making them progressively more and more compact, so that's going to be easier to manage. And we're installing a traction system. So this is the system. We now have about 30 sold, and we're sort of pushing forward, making it more compact and bringing this to the market. This is a point that we talked about earlier, which is there is no, the application is very focused on the plant and not electrifying the whole soil. So there's no electrification of the soil, only the plant and the root. So what matters is it's systemic, so it's a root, which means less intervention, right? You have 2 or 3 months before it regrows, depending on the soil, depending on the type of plant. There's no water usage, no chemicals, respectful for biodiversity, and it's quiet. When we look at the solutions that we have, we can say the following. Electric weeding is platform agnostic, which means we can use different types of vehicles, different sizes, different geometries, to put electric weeding into the plants. You see here we have a partnership with Case New Holland, so we've initially mounted our systems on tractors. You see here this is in Versailles. This is mounted on a New Holland T4 tractor used in courtyards there. This is mounted on the tool carriers. This is about 1.20 m width. We're now launching at Demo Park an 80 centimeter width front applicator, and progressively working with other vehicles here. The Zap Wheeler we talked about. We have a partnership with the Group Verschuren in Brussels to mount the same front applicator on a hydraulic arm, and that's great to access areas that are difficult to weed otherwise. The small one here on the left is, oops, look like this one. This is a new handheld, which is, for now, is linked to the supply unit, so that the operator can get out of his vehicle and do the last part of his treatment using a handheld. It's an add-on tool to the CityZaz. At some point it will become its own separate tool. And then I was just showing in what we do in agriculture. We do in vineyards, in orchards, but also working in narrow vineyards, and in Brazil, in citrus, coffee, and other crops. We have about 200 devices running, both through sales and leasing. Yeah, in terms of applications, we talked a lot about different ways of doing this, and the possible role that electric weeding can have in an integrated grid management. So here, whether it's alleyways, sidewalks, airports, courtyard, etc., solar panels. At airports, we're getting more and more demand. There, the two issues have always been risks of electromagnetic interference with the control towers, which we have now addressed. So it's not an issue, and also the potential risk of electrodes touching the lights on the runway. And so we had to go deep into how they are embedded on the runway. So every situation has its own set of questions, but in some cases people go to electric gridding because other solutions may or may not be acceptable. Yeah, gas side, this is done through a service provider that is doing not just their side, but also other castles around it. This is the perfect kind of situation where the owners don't want too many interventions, they want something pretty quiet. So we do this, and you see here the effect. If you don't speak French, it's before, right after, an hour and a half after, and 24 hours later. I mean, the effect is immediate. The plants are killed right away, and you typically see the effect in a couple of hours, depending again on wind density, but it's quite powerful. Beyond wind, so we talked about addressing a problem that more and more people have now is how to treat invasive plants, and can the power of electricity be used to treat invasive plants. And a lot of you are familiar with the Woodwave Pro, which is now called the Kirsten lens, electric reading lens, which is really powerful, and that's great that this product is already out and being used. At the moment, we have clients using this solution here. So this is a situation in 2023. And this is the output of a 2-year report. They went on the field 5-6 times, and what they essentially see is excellent result, or at least a great reduction of growth. And the way we do this, we look at this is the number of plants per square meter and the diameter of the stem, among other indicators, to see the evolution over time. So we're doing it right now with those solutions we have. Later on, we will have our own handheld, but it's clearly something that the market is asking. The market is also asking about soil and biodiversity. We take it very seriously, and clearly this was a question that at least farmers were asking about earthworms before asking about the price of the devices, and they were very keen to make sure those earthworms were happy and that the microorganisms were respected. So we did a lot of tests, and we can confidently say today that there is no long-term impact, that the integrity of the soil, the ecosystem is respected. And on the agro side, it's compatible with biological agriculture, so we feel good about it. But this is something that we will continue to confirm that we've done a lot on this front. So it's compatible with regenerative agriculture and compatible, I think, with expectations from the public. Safety, of course, is absolutely key. We cannot smell electricity, you cannot see it. It's something that's new. And so a lot of efforts were done in the early years, one, to educate the agencies, the certification agencies, to find all the norms that could be applied, to go through risk assessments, to understand what are the mitigating factors, and to come up with a plan before we can apply the CE certification. And so this is a typical pyramid scheme where you start with a concept, you think about the materials, you think of the materials that are non-conductive, the one that will isolate the high voltage area, and you think about software features, visual warnings, acoustic warnings, and you think about ultimately how to train the operator. So every delivery comes with training, and everything is designed to be safe. So yes, boots have to be used. Equipment has to be stored in a right sort of covered area. But this is something that now we do quite well, and we haven't had any issue over the last 8 years. Yeah, just some examples here. This particular machine has a 360 camera, so whenever someone approaches within 3 meters, the system shuts off. 3 meters is a safety zone, a comfort zone that the EU directives have told us. We're using the machine directive, we're using the other directives and certification to be able to apply this safety concept. So a lot has been put in place to make the system safe. Now, looking ahead at what we're doing, just to give you a flavor, some of this does not apply to your needs, but essentially, it's because electric weighting is platform agnostic, we're working on a number of possible platforms. On the agro side, it's moving from specialty crops to cash crops, starting with Brazil, and then on this kind of solution, working on more compact one, but also working with electric tool carriers to make the whole system fully electric, and then launching the smaller solutions. So more compact, more intelligent, easier to handle, and moving from non-selective to selective. So today it's non-selective. The selectivity is done through the geometry of the applicators. Ultimately, and you've seen all this plant recognition AI to try to be smart about it. We'll get there. The market is big enough right now to just really do a good job with non-selective weeding along sidewalks. So just to finish, electric weeding, it's effective, it's scalable, it reduces chemical usage. Because the regrowth is 2 or 3 months, or at least you can bet on a reduction of workforce. It's safe for the operator, it's safe for the microorganisms, and it's but ultimately we would like to have electric weeding be part of the IWM concept. So when we talk about mechanical and thermal, our objective is to put electric not just as a sub-bullet point of thermal or mechanical, but to have it as a proper mode of action that's really considered, and that's the case already in some countries in Europe. So we would love to just have you start thinking about electric weeding as a possibility, understand better the safety side of it, the efficiency side of it, and see how you can potentially integrate that into your portfolio solution. It's not a miracle solution. It has limitations. We can talk about them, but we think strongly because of the root action that it can be an interesting tool. And I think that's it. Zasso, we're a small company. We've got 20 people in Europe, another 20 or 30 in Brazil. It's family owned. It's my family and that of my business partner, Sergio. And I would just maybe end this slide. Electric weeding is not new. It's been around for 100 years. What we've done is, and we're not the only ones, there's about 3 or 4 companies doing this, is to make it viable, commercial, safe, and applicable for your needs. Thank you very much.
The cost of operation that people
the cost of operation is actually low. So if you look at the total cost of ownership of a solution, you have an upfront investment, but then the actual annual cost, you don't have to pick up hot water, you don't have to take a gas. It's really the switching of the electrodes every 3-4 months, depending on your usage. So there's no wear-in parts except for the electrode that you have to change maybe 2-3 times a year. Yeah.
Have you tried in an urban environment where there might be water pipes or telephone lines in infrastructure within the pavement, and maybe houses within the 3 meters? I suppose you wouldn't be able to spray a terrace street.
Yes, we did 2 things. One, we did theoretical simulations to demonstrate to the agencies that the conductivity will not impact optical cables or medical equipment in a hospital within X meters. So we've done a lot of scenario analysis to demonstrate that there's no EMC or electromagnetic impact on the surrounding. Simulations and then practical experience with our service providers.
Water pipes.
And specifically water pipes, yeah. And it's always a challenge to have those kind of systems in an area that is quite dense. We have a safety concept that includes either blocking the street or having this 360 camera, but typically the 3 meter zone has to be respected. And it's 3 meter because if a pedestrian is within 3 meter and falls, he may fall towards the active electrodes. Now, the system can be very quickly, for the walk behind that we have here, as soon as the operator sees a danger, he can release the double handle, and that's it. There's no residual current as soon as the operator removes the hand. Hi.
Spraying in France in urban areas isn't allowed.
Oh no.
Oh, and how are they all coping over there without being allowed to spray pesticides in
No, I mean, the mayors are desperate because they're looking for solutions. The French public is quite keen not to have chemicals for years now. So there's plenty of solutions that work. Hypalurine is a wonderful solution in many segments. So we're here to bring an alternative. We see a lot of interest for this kind of solution as another one in areas where you cannot use mechanical weeding because it's projecting small pieces, etc. So this is innovative. They're very cautious because it's the first innovation. A lot of companies have tried to bring innovation without good results, and so the mayors typically are cautious. But we have service providers who are essentially buying the equipment from Zasso and then offering a service to mayors, and they come 2 or 3 times a year. And just to be transparent, they would offer 1-day treatment for 1,500 euros or something like this, and then they would do it twice a year, efficiency guaranteed. So it's early days. It's all about reassuring the public that this is safe. Yeah.
I guess it just follows on from the gentleman's question over there.
Yeah.
Just in terms of your 3 meter wall,
Yeah.
obviously, if we was going to deploy something like this into our high streets, effectively,
Yeah.
most of our street furniture is steel, made of metal, the planters, the bins, everything like that. I guess that 3 meter wall would then still apply to that, or can you go right up to them? Is there a risk they're going to become live? So
No, what we do, so you remember the graph with the connectivity and the cross section?
Yeah.
It's really, so 3 meter is the safety zone.
Yeah.
The actual action zone is around 50 centimeters around the walk behind device, for instance. We don't recommend being really close to a metal fence, just because it increases the chance of doing a poor manipulation. But as long as you don't touch, there is no. The one risky situation is if you have a metal bar, you're driving above a metal bar, and the metal bar is not rounded. If it's rounded, that's fine. If it's not rounded, then if it can carry the electric, if it touches the electrode, it can then be activated, and then it can carry a danger outside the system. So that's, but most metal objects are grounded, and so it's okay. But it remains a safety topic, and we want to be very careful when we do training about those risks. Yeah.
I was asked about, sorry, go.
Have you encountered any regulatory barriers in trying to bring this equipment to the UK?
To the UK, not yet.
Not yet. Okay.
I mean, I don't know if you-
No, I mean we've done demonstrations, etc. There's not any on the market currently. Well, there might be a couple from Case New Holland with doing some of the tractor mounted systems a while ago. So there might be a couple in farms. But as far as I can find in the legislation, the legislation is consistent with the European legislation because we're not that long ago detached from them, and so it's considered safe to use with the same considerations in terms of ensuring that operators are trained, and that's an annual training, and that the machine is inspected properly annually and kept up to date in accordance with the operating manual, etc., and all the other types of standard legislation that would apply to machines that you would use normally anyway.
Yes, hi.
How far away are you from launching a machine that can be used on turf to select the users out?
So I'm not showing all the products here, but we have a functioning prototype of a handheld system with a backpack, which does spot treatment.
Excuse me.
Is that what you meant, or so it's spot treatment? So
we've been approached by a company in Belgium and one in France. Everybody's coming up with all sorts of ideas at the moment.
Yeah.
And we're not in the business of funding these things to get them off the ground.
Yeah.
We're a user
of course
when there's a viable product. We're already running autonomous mowers, and is there something along that line of product that would be an autonomous weeding machine?
Oh, that's different. So that's autonomous. So it's a different. So we have developed a vision system that we're going to start using in agriculture. So that's more for that side of the business.
Yeah.
We have a handheld prototype
Yeah.
to do some spot treatment on turf.
Yeah.
So just boom. Limiting factor there is you can only have X kilos on your back and X amount of power module, and so you cannot just apply a high amount of power. It's maybe limited to 1,000 watts. It's not great, so you need a time of application of more than 3, 4, 5 seconds. That goes to some area of time which is not necessarily comfortable for commercial. And on autonomous, which is putting core technologies on robots, we're not doing that yet. But is that, yeah.
On the subject of selective weed control, you mentioned that it was harder to control grasses than
Yes.
it was broadleaves.
To some extent, yeah.
Is it not possible to treat grasses at such a speed that it controls the broadleaves whilst leaving the grass, therefore being selective?
What is that?
Yeah.
Okay.
And I think that's the exciting thing of where we are now. What we've got today is what we've got today. What the future technology, when somebody says, well, can I do this? Can I do that? And I think that's the exciting thing that's going along. But we need to sell what we've got today to fund what we're doing tomorrow and the research into it. You know, if you think about the research that's gone into chemicals, pesticides, it's colossal. And we're just on the start of this journey, I think. I think that's probably one of the most exciting things that we've got coming into the future is that area.
Thank you, Chris. Thank you.